could access those files, or perhaps the classification for the URL depending on if it is an IP address or if it is a name when referring to your local machine, perhaps it's not a big deal while analyzed on its own. But let's see how can we combine all of those features to carry out an attack. We'll discuss two scenarios. The first one will have less steps and will be intended to cover a scenario in a local intranet where users have shared folders to exchanging documents, music, and so on. And the second will be more general, will cover the common internet user directly connected to internet. Well, the first scenario here has this series of steps. The attacker have to manage to put HTML files in the victim's shared folders in a network, in a local internet environment. This is quite common to find shared folders with right permissions. So someone in the network could just put an HTML file in there. Then this malicious employee in the company could send the user a link so the user clicks on that link, and then a redirection occurs towards that file. In that way, the attacker could put a malicious HTML file in the shared resource, and after clicking on the link the attacker sent to the victim, the victim gets redirected to the resource that the attacker uploaded to the victim's computer. So if this occurs, the attacker will have HTML code and script code running in the context of the victim's local machine, but with the privileges of internet, as we saw that it is the classification. This is actually indeed the victim's computer, but the privileges of the code running there will be as if it was a site belonging to the internet zone. Well, the most general approach is a bit more complicated to be carried out, but it is easily understandable after seeing all of the things we have been discussing so far. Basically, an attacker just should entice a potential victim to click a link to a malicious website. This website has to contain an image tag with a UNC path to the malicious server, as we saw before. This way, the attacker could manage to obtain the victim's actual username. That username will be needed to carry out the attack later on. In the meantime, this malicious web page the user is visiting will write in the victim's computer tracking files malicious HTML code. Then the server will be running scripts based on the information it obtained through SMB. Will be running scripts so to build the right paths to the internal tracking files that, as we saw, are located inside the user's profile. That's why we needed the username. So these files the server is building will be referenced together after a redirection. At this point, the trick here is to force some way to when redirecting the navigation to these files the server wrote in. The trick is to to force Internet Explorer to render, to treat those files as if it was HTML code. This is something that has been done many times already, and given the nature of the feature itself, given that it is not actually a bug but a feature, they cannot simply remove it. In fact, what Microsoft is doing so far is just preventing our proof of concepts from working, but every time they did it, we managed to find another way to do it again. So this has a lot to do with the complexity of the MIME tab detection. And well, if an attacker manages to perform that, will have the same impact as the previous scenario, that is HTML and scripting code running in the context of the victim's local machine, but with Internet zone privileges. So, as a result of this attack, in the process, an attacker is able to store HTML and scripting code of their choice, of her choice, in the victim's computer. And by the redirection mechanisms, is forcing the victim's browser to load and render this HTML code. And as we said, this code is actually running in the Internet zone, but is also running in the victim's local computer. So it has at least enough privileges to access every single file in the same origin. It doesn't violate the same origin policy. It doesn't violate the security zone scheme, the zone elevation. It's all right. It's according to the rules. So it can access a lot of interesting files, as we can see. We will see this in a demonstration right now. And well, before anything, this process of forcing Internet Explorer to treat a file as HTML has been done in 3 advisories so far. The last one is being published today, and it will be available. I think it should be available right now in the Core Security website. And the only difference between each of these vectors is the way in which Internet Explorer was tricked into rendering those files as HTML. And also, perhaps the difference was which files were used in each of those attack vectors. In the first one, I managed to use the cookies for this purpose. And in the latest two, the file I used is the index.dat that is used for navigation tracking. And as this is the only thing Microsoft is fixing, Microsoft isn't fixing it. It's just twisting it a little bit so this proof of concept doesn't work, because they cannot fix something that is not a bug, it's a feature. That's a problem. And that's the reason why we are still doing it over and over again. Well, let's see if it works. Let's see if all I've told you it's actually true. For this demo, what I will do here, I have built a module for BIF. BIF is a cross-site scripting exploitation framework. Most of you should have heard of it. What I will do here is just open Internet Explorer and do what an attacker will do in this case. Point a victim to a malicious website. If you have used BIF before, you will recognize this URL as it is the default connection page for BIF. So once the user is visiting